Recently, I purchased a UniFi E7 access point. The received box is much heavier and bigger than I expected. It is really a monster. Just for comparison, the left one is the U6 Enterprise Invar, the right one is U7 Pro Max. Even though the U6 Enterprise Invar is also square, it's just like a baby compared with the E7. And the U7 Pro Max is already big in my opinion, but it's nothing compared with this E7. This is their back view. E7 has two parts. They are both PoE++. The U7 Pro Max and U6 Enterprise Invar, they only have one part each. After connecting the E7 to my system, of course, the very first test I want to do is just to test one single Wi-Fi 7 client to see the maximum speed I can achieve. So I already set up a SSID for the E7. You can see it's only broadcasting using E7 and it's only using 6 GHz Wi-Fi band. And if I go to the E7 itself, for 6 GHz, you can see I choose the widest channel width. For channel, I set Auto. I already enabled the 6 GHz extended range. Then in the lower right, for the Windows client, it's using a Intel BE200 chip. It supports Wi-Fi 7. As you can see, the speed showing on the Windows client is this seemingly very good speed, more than 5 gigabit each direction. And in the UniFi network controller, if I go to clients, for this Wi-Fi client, it's not really showing the same TX rate and RX rate. I trust the network controller's display. Maybe the Windows client is simply not updated yet. If I run iPerf3 testing against a Linux machine, let me see what speed I can get. Let me run iPerf3 client, 10 parallel connections. Let me see what's the speed. Okay, more than 4 GB, super good, right? Then if I test another direction, -R, meaning receiving or downloading. Okay, it's not as good as uploading, close to 2 GB. What if I say bi-direction, which means both downloading and uploading at the same time? See, in the Linux server, the uploading is still close to 4 GB, but for downloading, it's very bad. This is the first problem I saw for this E7 access point, which is if you are doing the downloading and uploading at the same time, the downloading speed is very slow. I will talk about this later in the video when I do more speed testing. About how to connect the E7 to your existing system. It has two parts and it needs PoE power. So there are multiple combinations you can hook it up to your system. In my previous videos about E7 high availability, I already covered different combinations of providing power and providing data connections to this E7. So in this video, I will not repeat that again. Please check the E7 HA video if you are interested. E7 has real-time spectral analysis and it has dedicated spectral analyzer radio. I already covered U7 Pro Max spectral analyzer in one of my previous videos. For E7, it works in the same way as U7 Pro Max. But there's only one thing I want to mention here. If you go to the radio manager, go to environment, now you see the spectral analyzer. You can see you can switch between the 3 Wi-Fi bands here, but you cannot check different Wi-Fi bands at the same time. you may think, okay, what about I launch another browser window and go to the Spectral analyzer again? For example, here I click 5G, then am I able to analyze 6G here in the upper side browser and 5G here in the lower side browser? Let's see whether it works or not. See, this is what you get. If you launch a new window, yes, the new one will be working, but your old one will show this error. Spectrum scan is already open in another session. So you cannot scan two different Wi-Fi bands by using one single E7. Okay, another big feature for E7 is about the long-range 6 Hz performance with AFC. I already covered this in very detailed way in my video for AFC, so I won't waste your time in this video again. To test the performance of the E7 access point, I set up this very busy lab environment. For each Wi-Fi band, I have 3 separate physical clients. For 2.4 GHz, I use 3 Windows machine, 5 GHz, 3 Mac machine, and for 6G, I use a PC with the Intel B200 chip, which will use Wi-Fi 7, and then a Mac Mini. It supports Wi-Fi 6E. I connected to the 6 GHz, and a Google Pixel Android phone. It also supports Wi-Fi 6E. And in the server side, I run 3 Linux virtual machines. All of them are connected to the switch using 10 gigabit Ethernet connection, and for each Linux server, I run 3 separate iPerf3 servers. So in total, I have 9 iPerf3 servers, and from the Wi-Fi client side, I have 9 clients. And you may know E7 support more than 1,000 connected devices. Of course, I don't have so many Wi-Fi clients, but for each connected Wi-Fi client, when I test it, I'm going to use 10 parallel connections just to simulate more Wi-Fi clients to add more loads to the E7 access point. Okay, in UniFi network controller for Wi-Fi, I already set up 3 SSIDs. For example, this 2.4 GHz SSID, you can see it's only broadcasting using E7, and it only uses 2.4 GHz. For the other two, I have a similar setup. I use 3 separate SSIDs from E7. Just want to make sure each client, when it's connected to E7, is using the supposed Wi-Fi band. And then for the 9 Wi-Fi clients in the right side, I already connected them to the proper SSID. If I go to E7 in the client list, you can see now I have exactly 9 Wi-Fi clients connected, 3 for 2.4 GHz, 3 for 5G, 3 for 6G. So now I'm ready to kick off the testing. For each Wi-Fi band, I will show you the spectrum analysis. Let's start from 6 GHz. So the system needs some time to make the spectrum analytics ready. While we are waiting, let me start all the 9 iPerf3 servers in the 3 Linux servers. Because for each server, I'm running 3 separate iPerf3 servers. So I need to indicate different port number. For this example, 8881. The second one, 8882. Third one, 8883. So in the same way, let me start all the iPerf3 servers in all the 3 Linux servers. Okay, they all started. From the spectrum analytics, you can see for 6 GHz, it's very quiet. There's nothing going on. Let me start the first Wi-Fi client, starting from the Windows machine. The way I'm going to run the iPerf3 client is I make it run for a long time, parallel 10 connections. Then, very importantly, I run it in bi-direction mode. And then I specify the proper port number. And because I need to run it in bi-direction mode, you can see even though this is a Windows machine, I'm running the command in the Linux subsystem just to use the bi-direction mode. Okay, start it. Then for the second client, then on the Android phone, run the same iPerf3 command. Okay, for 6 GHz, it's using the 101 channel. So that's why you can see for this area, it's very busy now. And from the waterfall, you can see some very dark red areas. For 6 GHz, I don't see any packets dropped from the Linux server. Let me show you the network activity. So you can see even though I'm running 3 parallel clients, the total throughput is not very satisfying. Now let me switch to 5 GHz clients. From the UniFi network controller for Spectrum analytics, let me switch to 5 GHz as well. Okay, similarly, now it's very quiet because I haven't started the testing yet. So from the first client, kick it off. Second one. Okay, third one. All started. Then let me show you the network traffic. So you can see for 5 GHz, the total throughput is much lower than 6 GHz. Of course, it's due to the clients, not due to the access point. And then from the waveform and the waterfall chart, you can see the red areas, especially for the waterfall. This area is very, very dark red. That's why from time to time in the clients, especially the third client, you can see some serious packets dropping. You see the zero traffic, right? That means the packets were dropped. Why? Because you can tell from the waterfall. Because it's so busy, it simply cannot support so many concurrent connections. Then move on to 2.4 GHz, switch the Spectrum analytics. Even though I haven't started testing yet, you can see they are already very red. That's expected because from my home, from my neighbor's home, there are a lot of 2.4 GHz devices running already. Okay, then start the testing. A second client, then the very last client. Then in the Linux server, let me switch to the network traffic chart. See the 3 Wi-Fi clients. I see very serious packets dropping. See the third client, most of the packets are being dropped. Why? See the Spectrum analytics for this area is so busy. It's so dark red. It's too much running so many parallel connections to saturate the bandwidth. Okay, in total, see the 3 Linux servers. If you add all the current throughput up, of course, it's much lower than the theoretic E7's throughput, right? But that's expected. Of course, we don't expect to get all the 10 GB throughput on the air. But I do see a problem. That's about the uneven throughput between upload and download. For all the 3 Wi-Fi bands, they have the same symptom. From server perspective, the receiving or downloading is very fast, but sending or uploading is very, very slow. So this is from the server perspective. From the client perspective, that means the downloading is much slower than uploading. So this is a pattern I can see for this particular UniFi E7 access point. I'm not sure whether there's anything wrong with the firmware. If you have any insights, please let me know. But I hope in the future firmware upgrades, this issue can be addressed, because I cannot explain why I see this type of problem. The last part of the video is about the super hot temperature for this E7. This is the upside. You can see in the middle area, the temperature is over 130 Fahrenheit. And the backside is much worse, over 145 Fahrenheit. You cannot even hold it. Okay, this is the end of the video. Thanks for watching.